Assalamu alaikum. In the previous video, we have learned about tangential acceleration. In this video, we will discuss centripetal acceleration. For that, I consider a circular path on which an object is said to be moving in anti-clockwise direction, in this direction. When the object moves, the velocity of the object may possess a certain velocity. This velocity is nothing but a vector quantity. It is a vector quantity. So it has got both the magnitude and a direction. In circular motion, the direction of velocity changes continuously with the time. If the object is present here, now the velocity, the direction of velocity can be obtained with the help of a tangent. So this is a tangent. Tangent is the line which goes touching a circular curve. Now for better understanding, here I take this point as the center of this circle. Okay, then I connect this object to this center. Okay, fine. Now here, if you look at this, diagram carefully, you may find that the angle made between the tangent and the radius is nothing but 90 degree. Is 90 degree. It means these two lines are perpendicular to each other. This clearly shows that velocity always acts perpendicular to the radius of the circular path in which the object is moving. Okay, clear? So here it is velocity. Now we have also learned one more thing, that acceleration which acts along the tangent is called as tangential acceleration. I represent letter AT, vector. Okay. Now what is the centripetal acceleration? It is the acceleration which acts towards the center. Acceleration which acts towards the center is referred as centripetal acceleration, and it is perpendicular to the tangential acceleration. Okay, remember this. Now take for one instance that the object has shifted to a new position. Okay, this is the new position of the object after some time. Then here the tangent again provides the velocity vector. Now here I take this as v2 vector. So just to show the difference, I take this one as v1 vector. Okay. Now here the line which connects the center to this object is nothing but this, which represents the radius, and along this the centripetal acceleration act. Okay, again you can see they are perpendicular to each other. So here I have two velocity vectors. This represents v1 vector, this represents v2 vector. Now what I will do, I'll draw a line which is in the exact direction of this line, or which is parallel to this line. See, I draw a line here. This is exactly parallel to this line, and it represents the v1 vector. Okay. So this side, if I close this side, then it gives me a vector which provides us the speed. Okay, the delta v vector, it gives the difference between these two velocities, and from this we get a speed. Got it? And here delta v is change in velocity, delta v vector, and it is the difference between v2 vector and v1 vector. In a similar way, these two lines, apart from centripetal acceleration, they also represent the radius. Okay, they represent the radius, which I take in this manner, acting in this direction. So this is taken as R1 vector. Now this provides a position of the object at one point, and this line gives the position of the object in another instant. So this is represented R2. Here R1 vector and R2 vector provides the positions of the object moving in circular path. Clear? Now by keeping this in mind, let's say the angle subtended by these two lines is taken as theta. It is so. Then just I take it out, or I take it this way, and this line is taken in this manner. This one is another line. It represents R2 vector. This represents R1 vector. Now I close them by connecting them together in this manner. Then this line provides me delta R vector. Okay, and it is nothing but the difference between R2 vector and R1 vector, and this gives the distance. Yeah, or correct speaking, displacement. Right? So displacement is obtained by subtracting R2 and R1 vector. Okay, so this is how one can get the speed of the object and the position of the object using geometry. Okay, clear? Similar way here, the angle made between these two is also taken as theta. Clear? Now I'll go ahead. I'm going to find the relationship between delta v vector and delta r vector to get the expression for centripetal acceleration, which is represented by letter AC vector. Let's do it. Relating delta v vector and delta r vector geometrically to get the expression for AC vector. Okay, let's do it. So what I'll do now? Here, I take this delta v vector and divided by v. Okay, a similar way, just I take its magnitude. Let me mention this before. So before doing, okay, I'll write it first. And this side, use the delta r. It is found to be equal to delta r upon r. And here, one thing I do want to tell you is, here this ratio should be provided with the negative sign. Here negative sign implies that the centripetal acceleration acts towards the center. Okay. Here minus sign shows that the centripetal force acts towards the center. Yeah, remember that's why we have this. Now this what is this ratio? This ratio is nothing but theta, and here theta is the angular displacement. Okay, I think you remember this. I have informed you, or I have explained this in the previous video. What is that? Angular displacement is nothing but length of the arc. Length of the arc. Length of the arc divided by radius of the arc. Radius of the arc. Yeah, here see, here length of the arc is actually this portion. This is the length of the arc. Which is nothing but delta r from this diagram, delta r. And the radius of the arc is nothing but r. Now both of them have got the same value, so it is taken as r. Actually, r is the modulus of r1 vector, which is also equal to the modulus of r2 vector. In the similar way, v is the modulus. Modulus means magnitude. Okay, modulus of v1 vector, which is also equal to the modulus of v2 vector. Okay, remember, keep this in your mind. Now, I think you would have understood. Or I will write this alone here for a better understanding. Here, angular displacement, represented letter theta, is found to be the ratio of length of the arc divided by the radius of the arc. Radius of the arc. Now we have got two diagrams. This is one diagram, this is another diagram. Here, this line represents the arc. This number here, this represents the arc, which is shown by this pink line. Whose value is delta r. Understand? Now here, the place of length of the arc, the place of angular displacement, I take a theta. The place of length of the arc. What is the length of the arc here? It is delta r from this diagram. And the radius of the arc is r, taken as r, which is found to be equal to, I take another geometrical diagram. There length of the arc is delta v, and the radius of the arc is, according to this one, is v. Yeah, and here as it acts towards the center, use a minus sign. From this expression, I will get the value of delta v. So for that, I take only this part. What is that? Delta r upon r equals to delta v upon v. Here minus sign. Here I think you remember I had told you about delta in the previous video. Here delta represents a change, a small change. Okay, here it is the difference between delta v is the difference between v1 and v2. In the similar way, delta r is the difference between r1 and r2. So in simple word, it represents the change. Okay, remember that. Now from this, delta v is minus delta v is kept here as such. V is taken that side. So what it will do? It will multiply with this part. We get v upon r multiplied with delta r. Got it? Now, this can also be written in this way. So delta V. Now I have removed the minus sign, or I multiply these two sides with minus sign. Minus into minus is plus, and here we get the minus sign. Okay, V upon R multiplied with delta R. Clear? Now I will divide. I take this one as equation number 1. Now I will divide the equation number 1 with the delta T. Okay, when I do so, it has to be done both sides. So delta V divided by delta T equal to minus V upon R. Delta R is divided with delta T. So what I get if I do so? Here delta V upon delta T, change in velocity with the time is nothing but acceleration. This similar way, change in displacement with the time, change in linear displacement with the time is velocity, linear velocity. Okay, this I am going to use here in the place of this. I will write A, and in the place of this I will write a V. Got it? So A equals to minus V upon R, that is multiplied with the V. So what do I get here? At the end is nothing but this. A equals to minus V square upon R. I will box it. This is the final expression which provides us centripetal acceleration. Okay, so this can be written as AC equals to minus V square upon R. Here minus sign shows that the centripetal acceleration acts towards the center. Okay, remember this. No, already I have told you about this. Here this final expression can be related with the angular velocity. We know the relation between linear velocity and angular velocity is nothing but V is equal to R omega. So in the place of V, if I use this, suppose I take this as equation number 2, this is a 3. So I use substitute 3 in the 2. So what I'll get if I do so? Let's say the AC is a minus V square upon R. In the place of V, I write R omega whole square. Then get R. On expansion, I get R square omega square divided by R. So here square and R will cancel, and what do you obtain is something like this. AC equals to minus R omega square. This is another way of representing centripetal acceleration. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.